Hello everyone, and today we're going to be going over Python operators on W3 schools. Um, so let's get started. And as you can see, operators are used to perform operations on variables and values. I'm pretty sure we're all familiar with the first operator, arithmetic operators. Basically, just simple addition, subtraction, multiplication, division, etc. That's available to us in Python. So this example that's here, that's given, if we go ahead and run example, so it already ran for us, but it's going to print 15, and we could actually try -5, and it's going to print 5. So basically what this is doing is the computer wants to print out two numbers, 10 and 5, but because there is an arithmetic operator, an operator that's used to perform operations on variables and values, and in this case, this is the subtraction operator. It subtracts the two values over here, 10 and 5, to output 5. That's pretty much it. And I don't think I need to go over the first four because pretty common sense. I can go over modulus real quick. It prints out this over here, this 3 lines of code prints out 1, because modulus is the remainder of what you get after you divide x and y. In this case, it's x and y because it's x mod y. If it was y mod x, let's actually try that. You would get 2. So x mod y, if we change it back, the reason why you get 1 is because if you do 5 divided by 2, the answer should be 2, but there is a remainder 1 after. So that's why the 1 is outputted, and every time there is a remainder in a division, that's what you're going to output. So if the remainder is 0, then it's just going to output 0. And then now we have exponentiation. This is just exponentials, exponents, pretty straightforward. Whatever you have over here, the first number to the power of the second number, or in this case, it's x to the power of y, or 2 to the power of 5. That's how you get 32. Finally, we have floor division. This is kind of like regular division. The only twist is that if there happens to be a decimal, for example, 15 and 2, 15 divided by 2 is 7.5, and you want a result, or the result will round down to the nearest whole number, and so the answer will always stay at an integer. I think that's pretty important. And now we have Python assignment operators. So these are used to assign specific values to variables. So yeah, the first one is the most simple, and I guess, yeah, the most simple assignment operator that there is. And this example, x equals 5, you're literally just assigning the value of 5 into x. So now whenever you print out x and you type in print x into your whatever coding thing that you use, it's going to print out as 5. Okay, over here, now we have the plus equals. I think all the way up to here is pretty straightforward because we just went over them. It's the same thing as the arithmetic operators, but now we're assigning it to a certain value. In this case, all the examples use x. So we're assigning whatever we get all to the variable x. And if x already had a value before, we are doing this action to x. So as you can see for the first one, the plus equals, x plus equals 3 is the same thing as x equals x plus 3. So if x contained 1, if you do this operator, you are now going to get x equals 4. If x had 0, then this would just be 3. So I think that should kind of make it clear. Now we have the and symbol and equals. And now it prints out 1. And if you are familiar with binary numbers, so the AND, it's a bit wise function or bitwise operator, sorry. So basically what it's doing is you're getting this into binary number, and we know that this is 105, or so, what, 101, because it's 1 to 4. 2 to the 0, 2 to the 1, 2 to the 2. And we know that the binary representation of 5 is going to be 101 because 1 plus 1 is 5. And if this doesn't make sense to you, try searching up binary numbers, maybe on the internet somewhere. That way you will understand this better. But yeah, we have 101 for 5, and for 3 we have 011. And if you use the AND operator, we have to make sure that whatever is on the top here and the bottom, they have to be the same, whether it's 0, 0, or I guess 0, 0 will, or if it's 1, 1, if it's the same, then over here, we print out a 1. If they're different, then we print out zeros. So if you go ahead and run it, it's going to print out 1 because this is going to be 2 to the 0, 2 to the 2, 2, or 1, 2 to the 2. But these are zeros, so we don't add anything for these. But because this is 1, it's basically saying this portion, whatever this is, it's lit up. And this is going to be part of x. And 2 to the 0 is 1. So that's the only thing we're going to be adding. Then if we try, let's say just 2 and 2 to see what happens. It's going to be 1, 0, 1, 0. Again, although these two are both 0, because they're not both 1, it's still just going to be 0. And then this, it's going to be 1. And 1, 0, it's going to be 2 to the 0 and 2 to the 1. But because this isn't lit up, we don't need to worry about this because this is a 1 over here. 2 to the 1 is 2. That's why we output 2. All right, the next operator, we have the OR. This is, the OR operator. It's the same thing, but let me just do a random. So this is again 5 and 3. But in this case, as long as one of them, the top, so this is the top and this is the bottom, as long as either the top or the bottom contains 1, it's still going to output a 1. So the top has a 1, so 1, 1, 1, 2 to the 0, 2 to the 1, 2 to the 2, so 4, 2, 1. And because they're all 1s, so this is all going to light up, and this is all going to actually equal the value instead of 0. So 4 plus 2 plus 1 is now going to equal 7. So 5 OR equals is going to equal 7. Now we have the XOR. This is kind of the same, but not really. And I'll show you what you mean by that. So XOR, it's only going to output the 1 if the top and the bottom are opposites of each other. So the top, either one of them has to have 1 and the other one has to have a 0. So in this case, this is going to print out 1 right here because they're opposites, 1. But even though these are both 1s, because they're the same, we're going to output 0. And now this is going to be 4 and 2. So it's going to equal 6. And then now we have the shift right and shift left operators. They're actually also shown over here. They're part of the bitwise operators. And over here, it's the same thing. It's you write out the binary numbers, but you're shifting left by pushing zeros in from the right and left. The leftmost bits fall off, and shift right by pushing copies of the leftmost bits in from the left and let the rightmost bits fall off. So basically, if we had like 1, 1, 1, if we're shifting right to right by 1, that we're basically just adding in a 0. We're pushing, think of it as actually just pushing this by 1 step. And there's infinite amount of zeros in the front. If you're pushing it by 1 to the right, then this rightmost bit, pretend there's like a cliff here, it just falls off the cliff. And now the next 3 numbers are going to be 0, 1, 1. So 1, 1, 1 shifted to the right 1 is going to equal 0, 1, 1. And the same applies for the left side as well. So hopefully that made that clear. Now we have some comparison operators. These, I'm pretty sure you're familiar with them from school, random the algebra from school. The equals. This is the same thing as just asking if the first number has the same value as the second number. And this is going to return false because 5 is not equal to 3. But if we just do 5 and 5, it's going to input true. I think that part is pretty straightforward. And then not equals, it's the same concept, but it's going to equal true because literally as the name of this operator, not equals, it's asking if x is not equal to y. And it's true because x is 5 and y is 3. So that's why it inputs true. And there's the greater than, less than, greater than or equal to, and less than or equal to, which I don't think I need to try because I think you guys know what those are. And we have Python logical operators, and logical operators are used to combine conditional statements. So over here, you see that we use the logical operators to combine other operators. And in this case, we combine 2 comparison operators. And the and both of these statements, both of these, in this case, comparison operators have to be true for or. Either one can be true. Either both can be true or at least one can be true. And then reverse the results, not reverses the result. So you have to think of the situation without the not. And pretend that the not is not there. And then if this inside line of code, if it returns true, then the not is going to reverse it to a false and vice versa. Now we have the Python identity operators, and identity operators are used to compare the objects, not if they're equal, but if they're actually the same object with the same memory location. So let's actually try this. Returns true if both variables are the same object. So we actually have, it prints out true, false, and true. Let's look at the first one. Print x is z. X is z. So this returns true because z is the same object as x. So there's something called memory address in Python or in other languages as well. But basically, it's really complicated. But for this example, I'm going to assign the memory address of, for example, 1, 2, 1, and 2. So even though these two lists, they contain the same apple and banana, because this one, the memory address is 1 and this one is 2, this is variable compares the memory address and not what's inside. They don't care about what's inside. And that's why x is y returns false. But in this case, x is z returns true, because over here, this equal sign, whatever is in x is also assigned to z, including the memory address. So everything, the content of the variable as well as the memory address in 1 is all moved to z. That's why it returns true. And for the last statement, this is what I was talking about. The equal is used to compare the content inside the variable, and it returns true because they both contain apple and banana. But because their memory address is different, that's why the second line is false. Okay, and then is not is the same thing, but the same thing as is, but when they're opposites. Now we have Python membership operators. Membership operators are used to test if a sequence is present in an object. So in operator returns true if a sequence with the specified value is present in the object, and not in is just the opposite of in. So let's actually try this one. So banana in x, it returns true because there's a sequence with the value banana in the list. I think that was pretty straightforward. Like for example, if we just put ban in x, it's going to return false because there is no ban. Finally, we have the bitwise operators. We actually went over these in our assignment operators, and they have the same functions as what we saw in the assignment operators. So we have the AND operator, sets each bit to 1 if both bits are 1, or sets each bit to 1 if one of the two bits is 1. XOR, it's if those two are opposites. Not, it inverts all the bits. And then the shifting, left shift and right shift. I guess the not, I could explain it. If it was like not 5, 5 would be 1, 0, 1, then it would turn into 0, 1, 0. It literally just flips all the bits. So 1s turn to 0s and 0s turns to 1s. I think that's it for operators. So thank you for watching. And yeah, if you have any questions, please feel free to leave them down in the comment section. And I hope to see you guys again. Thank you.